Hey guys, so go ahead and get out your notes page because we're going to be talking about graphing linear equations from what's called the slope-intercept form. Now there's a really good reason why it's called that, and we're going to talk about that right now. So here's a formula that you may have heard before that should be on there. It's called y equals mx plus b. All right. Some of you have probably heard that before, but we want to really dig into how we can actually graph equations that are given into this form. So, with that being said, we all know what y and x represent. X are the values that we put into the function that give us some y value. Now, here's the ones that you may not know as much about. We've got m right here. Okay? We're going to write down here on this blank, slope. Now, I talked a lot about slope in the last video that we were watching, and m is just that representation. So whenever you do rise over run, or change of y over change of x, or y2 minus y1 over x2 minus x1, all of those formulas are for finding slope, which is represented by an m. Okay. The other one we want to talk about for sure is b. Okay. So we've got this plus b here. Should have another blank. This one is the y-intercept. Now, the y-intercept is where the graph crosses the y-axis. So I'm going to draw a little graph right here, just so you can kind of see what I'm talking about. Okay? And then if I have a line like this, that's our graph, okay? This right here would be the y-intercept, because that is where it crosses the y-axis. And we'll dig into that a little bit more later on in the video, okay? Last thing I want to mention as far as definitions go is that the y-intercept is especially interesting because it also has another name. So, down here, we're going to write y-intercept is also called the zero. Okay? Let's dig into that just a little bit right now. Alright, so just real quickly, I want to explain why the y-intercept can also be called the zero, because this is something you're going to see. They're very interchangeable. So, first off, I'm just going to label a few points where x equals 0. Okay, so we'll do 0, 4, and 0, -3. Now, the reason I did that is these are some potential points where a y-intercept could happen. So you could have a graph that looks like this. Okay, so it's crossing the y-intercept here, or it's crossing the y-axis here, which would be the y-intercept. We could have a graph that looks like this. Okay, and this one, this line that I just created is crossing at -3. So the y-intercept for this top line is 4. The y-intercept for this bottom line is -3. Okay. Now the reason these are also called zeros is because they also represent where these graphs have x equaling 0. So this is our x-axis, right? So we're moving along. Here's 0. Okay, it happens to be right where the y-axis is. All right. So if you move up from 0, you go up here and you hit 4. 4 is the 0 of this graph. -3 is the 0 of this graph. It just refers to when x is equal to 0. All right, so let's go ahead and look at an example. We'll kind of walk through this and you'll start to see why things are named the way they are and kind of how we develop this graph. So, first example we've got here is y equals 3x plus 2. So we're just going to write a little reminder of the formula this is based on. Y equals mx plus b. All right? I like to do that because it reminds me of where all the variables should be and what it should look like. okay, in case we need to rearrange things. In this case, I think it looks good. We just need to figure out what M and B are in this case. So M is going to hang out with X always. So what's hanging out with X? That would be 3. So I know that M equals 3. All right, great. And M is our slope, so we've got our slope. Awesome. Let's look again. Now we're trying to identify B. It says mx plus b. It's always the number that's by itself over here. So I see the plus 2. That means b is going to be a positive 2. So we've got our slope. We've got our y-intercept. Now let's look how we translate that to a graph. All right, so now that we've got m and b, let's go ahead and graph this equation. I always like to start with the y-intercept, which is again our b. So we found b to be 2, and since we know that is where the graph should cross the y-axis, we're going to find 2 on the y-axis and plot a point. All right? Then, now that we've got our y-intercept, let's look at the slope. It says our slope is 3, okay? Which means that our rise over run, or our change in y over change in x, however you want to remember it, is 3. So that means if you wrote 3 as a fraction, it would be 3 over 1. So we're going to be going over 1 and up 3. And you can check yourself. Look how much it rises. It goes up 3 this way. We're going from 2 all the way up to 5. And then we're going across 1. So that's 3 over 1, which is 3. And the slope is positive. And from this point to this point, the graph is increasing. So we've plotted our line, or plotted our points correctly, draw our line, and we're all set. All right, so for this last example, I want to try something kind of tricky because this is the kind of stuff you might see on your independent practice. So, as you can see already, before we even write our reference formula, this does not look like it normally does. But let's go ahead and write it so that we can start figuring out how to maybe get it to something that we recognize. So, y equals mx plus b. Okay? Just going to keep reminding you of that formula. So, we know that y needs to be by itself. So you can almost treat this like you're solving for y. In fact, that's exactly what you're doing. So, in any normal case, if we were going to solve for this variable, we need to get rid of the stuff that's on this side. So, first thing I want to do is get the x over here, because we need the x over here for it to match this formula. I've rewritten the formula so that we can kind of see our steps a little more clearly. Alright, so we're going to go ahead and add 3x to both sides. Okay, because if you do something on one side, you got to do it to the other. Negative 3x plus a 3x cancels them out on this side so that you just end up with 2y equals negative 10 plus 3x. I'm going to put the 3x first, since that's the term that comes first in our formula. 3x minus 10. All right, we're close. We're really close, but there's still something attached to y. We've got this times 2. All right, how do we get rid of a times 2? We divide by 2. Okay, if you divide by 2 on one side, you get to divide the whole other side by 2. This 2y divided by 2 cancels out so that you're just left with y, okay, equals, you can divide each thing by 2 to make this simpler on you, okay? So 3x divided by 2, and I know this is crazy, but it's just 3 over 2x, okay? 3x divided by 2 is the same thing as 3 over 2 times x. Okay, this is important to remember. All right, then you've got a negative 10 divided by 2. If you do 10 divided by 2, that's 5. And then a negative divided by a positive gives you a negative. So negative 10 divided by 2 is negative 5. All right, so now if we compare this to our y equals mx plus b, you can see that it fits the form much better. So Now let's identify our m and our b just like we normally would. We know that m hangs out with x at all times, so that means m equals 3/2. Okay? And for our b, we know that it is by itself and it's on the side with the x. So we've got this minus 5. That is going to be our b, our y-intercept. And now that we've got both, we can graph it. We've already figured out that this right here, negative 3x plus 2y equals negative 10. When you solve it to make it look like this, y equals 3/2 x minus 5, gives us a slope of 3/2 and a y-intercept of negative 5. So, like I said, always start with the y-intercept. That's going to be the easiest thing to find right off the bat. So, our y-intercept is negative 5. I'm going to come down here to negative 5 on the y-axis, plot that point. All right. Then I'm going to look at the slope. It's a positive slope, so I know I'm going to be going up with it. All right, and it's rise over run, that is 3/2. So we're going to be going over 2, right? 1, 2, and then we're going to rise 3 as well. So we've got our rise 3 over our run 2. 3/2 is our slope, and we just draw our line through these 2 points, and there's our graph.